Hey all maths enthusiasts there, welcome to my channel Vedic Maths Tricks with me Guneet. Today we are unlocking another Vedic mathematical gem, that is first by the first, last by the last. This technique might sound like a riddle, but it's very powerful and easy. So now let's understand this technique with the help of an example. Before starting the question, there are certain things that we have to take into consideration. So first, we'll be starting with the two-digit numbers. So as the name suggests, first number will be multiplied by the first number and last number will be multiplied by the last number. And secondly, here the first digit of both the numbers are complement of each other, which means sum of both the numbers adds up to 10. And second digit is the same in both the numbers. Now, as we can see, 27 multiplied by 87, here first two digits are the complement of each other. 2 and 8 are the complement of each other. And the last digit, which is 7 and 7, are same in both the numbers. So now let's solve the question. So first of all, we'll make the partition. Here, as we know that the first number will be multiplied by the first number and last number will be multiplied by the last number. In the second partition, 7 multiplied by 7, and in the first partition, we will multiply 2 by 8 and we will add the second number, which is 7. So here 16 plus 7 and here 7 multiplied by 7. Now here 16 plus 7 gives you 23 and 7 by 7 is 49. So we get 2349 as the answer. Now let's understand this better by taking next example. Now here the question is 92 multiplied by 12. First digit of both the numbers are complement of each other, 9 and 1. And the second number is the same. So this trick can be applied here. Now make a partition. First number will be multiplied by the first number and the second number will be multiplied by the second number. So here 9 multiplied by 1, we will just add 2. So add the second number, which is 2 here, and in the second partition we will just multiply 2 with 2. Now here we get 9 plus 2 and here we get 4. The trick here is that in the second partition we need to have 2 digits. So here, since we have single digit, so we'll add 0 before the number. So 9 plus 2 gives you 11 and here it's 04. So the final answer is 1104. Now let's take some more examples. So it's 69 multiplied by 49. So here make a partition. 6 will be multiplied by 4 and 9 will be multiplied by 9. So 6 multiplied by 4 plus the second number, which is 9, and 9 multiplied by 9. So here we get 24 plus 9 and here 9 9s are 81. Since we already have 2 digits in the second partition, we don't have to do anything. So here straight away the final answer is 3381. Now here also the question is 21 multiplied by 81. We can see that first digit of both the numbers are complement of each other and second digit is the same. So this method can be applied. So here first number will be multiplied by the first number, which is 2 multiplied by 8, plus the second number and multiply the second digits in the second partition. So 1 multiplied by 1. So 2 multiplied by 8 is 16 plus 1. Now here 1 multiplied by 1 is 1. Since we only have one digit in the second partition, so we'll add 0 before the number to make it 2 digits. So the final answer is 1701. Now we will be using this technique in 3-digit numbers also. Now here the first question is 711 multiplied by 311. Now here, as we can see that first digit in both the numbers are the complement of each other and the second digits are the same, that is 11 and 11. So now this method can be applied. So make a partition over here. Now first number multiplied by the first number, which gives us 7 multiplied by 3, and add the next number, which is 11, and here 11 multiplied by 11. Now here 11 multiplied by 11, we can use the multiplication by 11 technique also. So what we'll do is first number as it is, add both the numbers, and here write the last number as it is. So we get 1 2 1. Now here 7 multiplied by 3 is 21. So but we have to be very careful here. When we are adding 11 here, it should be written as this. So here we get 221 and here we get 121. So the final answer we get is 221, 121. So for this technique, we have to be very careful for the first partition when we are adding the second number. Let's suppose here we added 21 plus 11. So the technique has to be like this only. We have to add like this only to get the correct answer. Now let's understand this better by taking more examples. So 216 multiplied by 816. Here also 2 and 8 are the complements of each other and 16 and 16 are the same. So now let's start. So we get 2 multiplied by 8 plus 16, and in the second partition 16 multiplied by 16. Now 16 multiplied by 16 can be done using above base method. So 16 multiplied by 16, the base is 10. So the deviations will be 16 minus 10, which is plus 6, and 16 minus 10, again plus 6. Now first number plus the second deviation, so 16 plus 6, and in the second partition multiply the deviations. So we get 22 in the first partition and 36 in the second partition. Now since we need one digit in the single partition as the base is 10, so this 3 will go and add up over here. So 22 plus 3, and here we get 6. So 256 we get over here. So here we get 256. Now here 2 plus 8 we get 16. Now 16 we'll add like this. 1 will fall under 6. So here we get 176 in the first partition and 256 in the second partition. So the final answer is 176, 256. Now let's take up some more examples of this method. Now the question is 115 multiplied by 915. So here also, as we can see, 1 and 9 are the complements of each other and 15 and 15 are same in both the numbers. So now make a partition. 1 multiplied by 9 plus 15, and in the second partition 15 multiplied by 15. Now 15 multiplied by 15 we can use above base 10 method. So here the deviations will be plus 5 and plus 5. So in make a partition, the first partition, first number plus the second deviation, which is 15 plus 5, and in the second partition multiply the deviations, which is 5 multiplied by 5. So we get here 20 and 25. Now since the base is 10 and we need to have single digit in the second partition, so this 2 will go and add up over here. 20 plus 2, and here we get 5. So 225 we get as the answer. So now here 15 multiplied by 15 is 225, and here we get 9. So 9, and we have to add 15. So 1 will come under 9 and 5 will be written here separately. So we get 105, and in the second partition it's 225. So the final answer we get is 105, 225. So now let's understand the last question. Here also, as we can see, that first numbers are the complements of each other, which is 4 and 6, and 17 is same in both the numbers. So the criteria applies here and we can go ahead with this method. So make a partition. 4 multiplied by 6 plus the second number, which is 17, and here 17 multiplied by 17. So here also 17 multiplied by 17 we can use above base 10 method. So 17 multiplied by 17. So the deviations will be plus 7 and plus 7. And here in the first partition 17 plus 7, and in the second partition multiply the deviations, which will be 7 multiplied by 7. So now 17 plus 7 gives you 24, and 7 multiplied by 7 gives you 49. Since the base is 10 and we need to have single digit in the second partition, so this 4 will go and add up over here. So 24 plus 4, and in the second partition we get 9. So answer is 289. Now 17 multiplied by 17 we get 289, and here 4 multiplied by 6 we get 24, and we will add 17. So 1 will come under 4 and 7 will be written separately. So here we get 257 in the first partition and 289 in the second partition. So our final answer is 257, 289. I hope you've understood this method, and I know that there are small tips and tricks that you have to remember doing the questions in Vedic maths, and this will only be possible if you will practice a lot. Vedic maths becomes very easy when you're practicing a lot of questions. So if you want my practice question books, please WhatsApp me on the number given on the screen, And please, guys, please hit the like, subscribe, and share button to motivate us to make more such learning content for you guys. And please share your suggestions in the comment box below. Thanks for watching.